Hi everyone, so for this video, I'll be showing you how to embed data on a web server. So as you can see here, we have a web page hosted by our Node MCU, and there's a data showing, and actually this is coming from a photocell wired like a voltage divider circuit. So every time I change the light coming or going through the photocell, its resistance changes, and since it's wired as a voltage divider, the output of the voltage divider is connected to the analog pin of the node MCU, and so the light intensity becomes proportional to the voltage output of the voltage divider, and you have your data varying with the light intensity. So if I cover the photocell like this one, so it shows 1024. That's actually the maximum value of data for a 10-bit ADC. And if I remove my finger, then it goes back to that value. And then if I add some light, right, from my cell phone right here, so that lowers the data value because basically the more the light, the smaller the value is, the darker the light, or the darker it is, the larger the data value is. Okay, so I will show you how I did this one in this video. Okay, first let me just show you how a photocell works. So I have here my photocell, and I have here a multimeter. Okay, so it's in resistance mode. Alright, so yeah, that's it. Okay, so a photocell is actually a photoconductive device, which means that if there's a light shining through it, its resistance decreases. Otherwise, if it's darker, then it has a higher resistance. Okay, so for example, if I will take note of the resistance of the LDR at this amount of light, right? So let me just remove the power first. Right, so the resistance would be, just remove it completely. Okay, so according to my multimeter, it's around almost 7. All right, let's do it again. Right, so it's actually around 5 kilo ohms, right? And if I cover it, which limits the light intensity towards it, then it exhibits a higher resistance. This time it's reading around 38 kilo ohms. Okay, now let me change this one to volts. Let me apply power to my node MCU. So this time my circuit has power. So this end and this end of the resistor are common or are wired in one pin, the A0 pin, the analog input pin. This end of the resistor here is connected to the positive source, 3.3 volts, and then this end of the LDR is connected to the ground. All right. So this is now the voltage divider circuit. And if I measure the voltage in the analog 0 pin or the A0 pin, and that is with respect to ground here, okay, we'll have a varying voltage that is proportional to the light intensity. So right now it shows around 2.687 volts. If I cover the photocell, it increases to 3.18. And if I remove it again, it goes back to 2.687 volts. Okay, so this voltage right here is converted to a digital value using the analog to digital converter of the node MCU, and that is the data that is showing in our web server. So we have here the Photocell. We have the 1K resistor here. So as I mentioned, one end of the resistor is wired towards the positive source, which is the 3.3 volts for on the node MCU. Then this pin and this pin of the LDR or the photocell and the resistor is shared on A0, okay, and then you have the other end of the LDR connected to ground. So this forms a voltage divider circuit. The voltage divider circuit actually follows this formula right here. So the output voltage, which is the voltage in here, which is the voltage towards the A0 pin, is calculated using this formula. You have the resistance of the photocell divided by the total resistance, that's between the resistance of the resistor in the photocell multiplied by the source. In this case, the source is 3.3 volts. Okay, so if this is the formula, and if your photocell changes its resistance based on the light intensity, so if it's darker, if our photocell value is higher, all right, then if it's higher, then you have a larger value of this ratio multiplied by the source, and you have your output voltage. If it's light, if there's light, the resistance value is smaller, and this ratio right here becomes smaller, and you have a lower value of output voltage. So basically, this is how the circuit works. So let me just show you a simple code, not actually the code for the project I show you in the first part of this video. I'll just show you the bare minimum of our code so that you can have an idea on how I managed to embed the data coming from our sensor to our web server. So we have this code right here. Of course, this is our required libraries. First is the ESP8266 Wi-Fi, a Wi-Fi client, and the ESP8266 Web Server. So if you've been following my videos, this is actually included already if you use the ESP8266 core for the Arduino IDE. So make sure you uh, watch that first video I have, because that is where I presented all the necessary things before you can code your Node MCU ESP8266 using the Arduino IDE. Okay? Then, of course, you need to provide your network's SSID and password. Then you create a server instance. This time, this uses still port 80 for HTTP. I have here a blank string which will house my HTML code later on. Then I have a double data, which is where the data coming from the sensor will be stored. Then for my setup, we have introduce a second of delay before I move on. Continue with the code. Then you have for debugging a serial monitor, and we begin the Wi-Fi connection. Just an empty line. Then this is what I usually do to wait for the connection to be established. Right. So basically, while the Wi-Fi is connecting, you will be seeing a series of dots on your serial monitor. Then once it's connected, it will tell you that it's connected to your SSID, and it will have an IP address. Okay, this is important because you need the IP address for accessing the web server using your local browser or any app that you can use. Then this is my homepage right here. This is a simple HTML with headers. So as you can see, I have my an H1 header that says that sensor to node MCU web server. Then another H1 that says data and column, and then another H1. Here I have a concatenation. So I concatenated the data variable. First, I converted it into string since my page is a string variable. So I converted data to string, and I concatenated it on the web page. And then this is now sent. to whatever client that visits the server. Of course, we have the 200 status code telling the client that everything's okay. Then this is now our page variable. We start the server, then we print out on the serial monitor that the web server started. Then on the loop, we have here the part where the Node MCU reads the data coming in through the analog 0 pin. So this is where the data is read from our sensor. Then it needs, or we need to introduce a delay of a second here because the ADC of the pin or the Node MCU is actually used by the Wi-Fi connection to detect or to measure the signal strength of the Wi-Fi, right? And since we are establishing a Wi-Fi server, then that would be constantly be happening in the background. But if you don't do a delay here, that means your ESP8266 could be both reading the Wi-Fi signal and the sensor value. So that would mess up your ESP8266. So it's better to introduce a delay here or of 1,000. You can actually lower this value. You can just test it, which one does not uh, create a bug. But for me, it's actually a second of delay, which works. And of course, I have server that handle client right here. This is important. This should be placed inside loop because this is the part where the Node MCU waits for any client that connects to its server. Okay, so if I will run this code, I will upload this code to the Node MCU. It will show this one. Okay, a very simple web page. But as you can see, the data value is not actually moving even if I try to cover my sensor. Alright, it actually changes the value if I refresh this page. So if I will refresh this page, right? Yeah, maybe I just need to reset. Alright, so it shows 888. Then if I will reset again, 886. Yeah, but it's not actually changing by itself. It's actually not changing unless we refresh the page. Just to show you that the code works, you just cover the sensor, then let's try to refresh the page. Alright, so recall, if you cover the sensor, it should produce a higher output voltage and a higher data value here. So here you see 1024 since we covered our sensor. If I will remove my finger and I will refresh the page again, it goes back to our ambient light value, which is around 880 to 890. Okay, so basically that's it for this code. But again, as you can, it's obvious, right, that the disadvantage of this code is that it that the page needs to be refreshed again and again for the data to be refreshed. Okay, so there's actually a solution to that, and that is what I will show you on the next part of this video. So the solution is actually to use JavaScript, particularly what we call asynchronous JavaScript, so that we can ask for values from the server without needing to refresh the page. So I used a simple script right here. So this is the function load data. All right. So this function has two parameters, a URL and a callback. All right. So this uses XML HTTP request, and it uses this on ready state change, which loads a function which checks if the page is ready and has the status of okay, and then it will call the callback function, which is in this case which is here depends on which function calls the load data. So what I did is use the built-in set interval function of JavaScript And then this is where I place the call for the load data function. The set interval is actually a function that repeatedly does something given an interval of time. So basically, the set interval function calls the function load data every second, right? So it calls the function. The load data function uses a temporary text file called data.txt. Okay, so this is the URL in this part. And then the callback function is update data. Right? So what happens is that if the URL is okay, it's if it's ready and if it's has or if it has a status of okay, then it proceeds to the update data, which this one. This is a function which embeds the data in one of the HTML elements on our web page. Speaking of the web page, this is the web page, right? So it has, of course, a head and a body. For the head, I just give it some meta for the viewing size, some styling, which is basically very simple styling, and then the link to the script, right? This is important. So the script.js, basically this one, all right? Then that's for the head. For the body, I have an H1 header. I have a paragraph which includes just a link to the tutorial on my website. And then here I have another H1 data column and another H1 which is actually empty but has an ID of data. So it has an ID of data. This is where the script embeds whatever the value is inside the data that text. Alright? Because as you can see here, it says that document that get element by ID data. So it gets any element which is an ID of data and then embeds the contents of data that text into that element. Okay, so the data that text contents is stored in this element right here. And if you'll ask, why use a data that text? There are actually a lot of ways to implement this one, but I choose this method. The way to explain the data text is through the sketch. Okay, so basically here I'll the same libraries, but we have an additional the file server for the Spiffs, which is what I discussed on the previous video. All right, and here this is basically the same as the previous code I showed you. The difference is that since we'll be using Spiffs, we need to check the status of the Spiffs. And then similar to what I did on my Spiffs video, we use the server on that found function. Alright? So basically we use a handle file read function which looks at all the files inside the Spiffs location and then hands out the status code depending if that file is inside the Spiffs or not. So if it's not inside, then it shows a 404. So the handle file read is actually defined in this sketch also. This is the handle file read sketch. Alright. So what happens is every time the script accesses the data that text right here, right? This is the part where the data, which is if you look at your loop again, this is where the variable from the sensor or the voltage from the sensor is stored. It is converted to string and then placed on text. Text is a string. And then the server sets this string to the client. Okay, the client in this case is the JavaScript. So essentially, the script, if it's reading data that text, the node MCU reads the data from the analog or from the sensor and then embeds that or writes that on data that text, and then this is the value returned to our script for embedding on that data element right here. Okay, And since this is AJAX or asynchronous JavaScript, we don't need to refresh the page for everything of this to happen, right? Because this is using XML HTTP request, so this happens in the background, and you don't need to refresh the page. One important thing also is that we use set interval so that we can have an update every second of the page, right? You can reduce this value to a smaller value to make the page updates faster. Here I use 1000 milliseconds or 1 second. So for this code, this is now what happens. So let me just refresh this one. I already uploaded the code on my Node MCU, hopefully. Okay, so this is now the updated code. And as you can see, the data changes and we don't need to refresh our page. And if I cover the sensor, it will have a larger value, right? And if I have expose the sensor to more light, then it will have a lower value.